So one of the things I'm not too sure about is how good we are with binary. Okay, we probably have a notion on this course that, okay, we know pretty much computers are electronic devices and they represent pretty much everything in terms of on and off or ones and zeros. Okay, so at a low enough level, you simply get down to registers that can store ones and zeros. Okay, so if I take a 4-bit register, okay, it's going to look something like this. Again, strangely, it looks a little bit like an array. That's okay. And this will let us store numbers, okay, binary numbers for that sake. And how it works is basically, okay, well, if there's anything in this first position, this represents the ones. If there's anything in the second position, this represents the twos. If there's anything in the fourth position, this represents 4, and so on. You get the idea. Okay, so if I want to represent the number, let's say 6, okay, to represent 6, then I don't need any ones, but I do need a 2, I do need a 4, I don't need an 8. Okay, and again, you can do the math. 4 plus 2 is equal to 6. Okay, so in a 4-bit register, we can represent the number 6, okay? Or we can represent any of these, the numbers that are possible with this register. Okay, so what is the smallest number we can store in this 4-bit register? 0. Okay, yep, I agree with that. Okay, so the smallest number that is possible is going to be all zeros. Okay, no 8s, no 4s, no 2s, no 1s. Okay, then what is the largest number we can represent? Okay, 15. 1 everywhere. That's a good way to put it. Okay, 1, 1, 1. Okay, so this is great. We can represent from 0 to 15. How do we represent negative numbers? If we only have bits, ones and zeros, this kind of feels like a, okay, well, great, you can put positive numbers, but we don't have any of these as minus. Okay, and this is what we call unsigned. Okay, so there's no positive or negative sign. Okay, so then the suggestion in chat is if we want to have a signed register, we have to make a sacrifice. Okay, so we have to then, this is all we've got. We've just got these registers that can hold 4 bits of information. Okay, and again, we do the same thing. This is going to be represent the 1s, the 2s, the 4s, and the 8s. The difference is we sacrifice the last register and we say, okay, this is going to be minus this. If there's anything in here, then we're dealing with negative numbers. Okay, so then repeat the exercise. If we have this being, let's take an example. If we want to have -6, okay, type what you think -6 would be in this 4-bit register. Just answering Anna's question there. Okay, so I got a string of binary numbers there. Okay, let's think about how we would do that. Okay, so let's take a different color. Okay, so we need to be minus. So it's implied that if we want a minus number, we have to have something here. So if you think about it, we start off with -8. What do we need to add to -8 to get to -2? Okay, so what we can do is, well, 4 would be too many. Okay, that would get us to -4. We don't need that. -8 plus 2 is going to give 6, so we can take that. And we don't need any 1s. Okay, so then repeat the exercise over here. What is the smallest number we can now represent in binary? Correct, and we got answers both in decimal and binary. Okay, so we had 1000, and that was -8. Okay, and to the largest number, yeah, we got it. Okay, perfect. I don't know where you learn binary at all in the switched education system, but again, yeah, we have a different number system. If we had a 5th register, the 8 would become 16, 32, 64, 128, and so on and so on. And it says nowhere consistently. I don't know if I'm going to add to the story. Okay, but anyway, we can sort of see, actually, this is kind of interesting because we have a number range here in the unsigned 4-bit register. We can go from 0, and then the maximum number is going to be, well, we have 4 bits, so it looks like, and because we use base 2, well, how do we get to, well, 2 to the 4 is 16, so 2 to the 4 minus 1 will give us the maximum number. Okay, so, and again, we have a 4-bit register, so we get our power from that. 2 to the power 4 is 16, minus 1 gives us the maximum. Okay. When it comes to the signed register, okay, what is our base 2 representation here? For the smallest, it's going to be 2 to the power of something. Is it going to be 4? What's the easiest way to express the -8? -2 to the 3. Thank you very much. Okay. And then our largest, well, we kind of already worked that out. Well, it's -7. So then we can have 2 to the power of 3 minus 1. Again, we've sacrificed this upper bit, so we actually lose a lot of numbers here just to be able to represent negative numbers. Okay, but now we at least have a sense. This is how we go about representing positive and negative numbers. Okay, and from this, well, at least from this, if we then had a 32-bit range of numbers that is signed, much like the Java integer type is, what is the base 2 representation for a 32-bit signed Java integer? So we could do minus first of all. Okay, we're going to have -2, and again, it's pretty simple. You just look at the size of the register. So it's 32-bit signed integer. Okay, so we have -2 to the power 31. And again, we're losing that bit because we've sacrificed a bit, okay? So this is, I guess, seen as a sacrifice. To be able to have more expression of numbers, we have to sacrifice the range, so we lose that bit. And of course, the positive then is going to be 2 to the 31 minus 1. Okay, so now when anyone comes up to you in the real world and says, what is the number range of a 16-bit register, you should be able to answer that pretty quickly. Okay,